Alright, welcome back. So today we are doing buffer overflow prep on try-hack-me. Alright, there's 10 of these rooms. Pretty much what you do, one or two of them. Pretty much the exact thing after that. So we're working on one today. If we have enough time, we may also work on two. Okay, very first thing we're going to do is RDP into the machine. It tells you exactly how to do it. The username is admin, password. Then all we need to do is just plug in the machine IP here, which could be 10.10.104.25. Alright. Cool, we're already RDP'd into there. I'm going to go ahead and minimize this real quick. We're going to minimize this screen also. And we'll go ahead and open up a new window. And I'm going to start from here. Alright, so now we're here. We can go ahead and move into a directory that I made for all this. Seeing desktop buffer overflow September, and this one's called Overflow 1. As you can see, I already got some stuff in here. Downloaded a whole bunch of stuff from earlier. That's okay. We're going to go ahead and we're going to remove a lot of these things. When we remove them, we'll just call them something else. That's all. Just so I can have all the stuff that I've already worked on for these buffer overflows and everything. So if we click on Overflow 1, it's more of a walkthrough style room. We'll kind of use the walkthrough a little bit, and we'll start to work on this guy. All right, and it also gives you a fuzzing script. It gives you a nice little actual buffer overflow script right here. So and it also gives you the bad byte array script. So that's nice. So with the fuzzer script, we can just go ahead and just grab that. All right, we can cat that fuzzer.py. Enter. And as you can see, this one's on Overflow 2 right now. I'm actually in Overflow 1. So let me go ahead and Sublime text that. Sublime fuzzer.py. And we're going to go ahead and change that over to Overflow 1. We're also going to change up this IP address too. Or also. Oh, I knew you were doing it, Audrey. Alright. So, there we go. Okay, we'll go ahead and save that, right there. And Windows machine, that's all opened up and everything. Let's go ahead and run this guy, and we'll see if there's any weird ports that we see open or anything like that. So we're working on Overflow 1 right now, right? So if I hit F3, we'll go ahead and get back into desktop. Alright. Vulnerable apps, OSCP. Alright, and this guy opens up. So we can go ahead and run him with an F9. And there we go, he's up and running. And now we can actually see, do we have any weird ports on here? Remember, you have to obviously run him before that port's going to open up. So let's do an mmap, tacpn, all that good stuff. Right, for the IP address of, I don't even know what, 10.10.104.25. And also kind of zoom in on this guy here too. Here you guys. There you go. Okay, 10.10.104.25, right? We got 139, 3389, 135, 1337. Alright, that's a weird port. Put netcat into that IP address, 1337. And we get welcome to OSCP vulnerable server. Alright, unknown command. What we're going to do now is we're going to type in Overflow 1 test. What was that? We type in Overflow 1 test, okay, and we get complete. So now we can also type in Overflow 1 run. Alright, and we get it complete. Cool. So that guy is up and running. Okay, so let's go ahead and see what we can do with him. So very first thing we want to do is we want to send our fuzzer at it. So let's go ahead and cat that fuzzer.py again. It's already on Overflow 1. Okay, we're going to send A's. There's going to be 100 A's at a time going across. It's going to connect to this IP address in this port. And we're going to send that string of 100 A's. It's going to sleep for 1 second. And it's going to keep doing that until it no longer connects, which will be when the program crashes. That's going to no longer connects, right? So we'll do our Python, fuzzer.py. And the program crashed with 100 bytes, and that's a total lie. So I don't believe that at all. Oh, want to know why? Because it's Python 3. It's a Python 3 script. See, it's still running over here, so that was a total lie. Okay, so we're going to do Python 3, fuzzer.py. And now it's going to start sending stuff off. As it's sending stuff off, I'm going to go ahead and try to get this thing to be a little bit bigger over here. Appearance, font. I believe it was font 6 is like the huge one. Yep. Appearance font 6. There we go. Okay, that changed everything over to font 6. So that's still running the program, and it's saying that it crashed at 300 bytes. I still believe that that's 100% a lie. So it might be going at a different program, wondering. Okay, there we go. Maybe it's because I started messing with it and it crashed. So like I said, this buffer overflow 1 is also more of a walkthrough style room. So we're just going to kind of wait for this guy to do its thing. While that's happening, we'll also grab that other exploit that they have here, since they already give us a nice little exploit. Alright. There we go. And the IP address is already in there and everything too. That's nice. Okay. And we'll go ahead and we'll Control-Shift-O that. And we'll call this Sublime Text Exploit, or we'll say Overflow 1 Exploit .py. We'll go ahead and copy that in there. And there we go. We'll save that for now. So it looks like we crashed at 2,000 bytes. Okay, so we crashed. I'm going to go with somewhere between 1,900 and 2,000 bytes. Alright, so let's go ahead and look at the program, make sure it did actually crash, and it did. We're on pause. Okay, we can go ahead and restart that program. So it's running again. And what we're going to do now is we're going to see where do we actually crash at. Okay, so it says 2,000 bytes. What we're going to do is we're actually going to make a MSF pattern, right? MSF pattern create. Okay, and then we're going to do a TAC-L, I believe it is. If I go back to my notes over here, fuzzy program, finding offset. Okay, we want to make a length, and we're going to make that of 2,400 bytes. We're going to make it 200 bytes longer than what it crashed at. That's all we're doing here. We're just making it 200 bytes, or excuse me, 400 bytes longer than what it crashed at. Just to make sure that we do crash it again. And we get this pattern like right here. Let's go ahead and grab this. Let's go back into our Sublime Text, and we're going to put that as the payload. And we're going to see where this program actually crashed at. Alright. Go ahead and save that real quick. And we'll go ahead and we're going to send that off again. So we're going to do Python 3 Overflow 1 exploit.py. So it's sent out to the even buffer and it's done. We sent off our 2,400 bytes. It hit it. It's done. Okay. So now what we have to do is we have to look at this EIP value. This EIP value of 6F43396E. We're going to take that EIP value and we're going to put it into our as a MSF pattern offset. So we do MSF TAC pattern underscore offset. The length, which is going to be 2,400, right? That's how many bytes we sent off. TAC Q, where did we crash at? And that was again 6F43396E. So 6F43396E. And that's saying that we crashed at 1,978 bytes. Cool. Alright, we can go ahead and throw that immediately into our offset up here. So it was 1,978. 1978. So what this exploit is going to do now is he's going to now send 1,978 A's at this program. We're going to then return with 4 B's. So let's go ahead and get rid of this payload now. And we can just leave it just like that. So if we look at the buffer, what we're doing is we're going to do the prefix, which is overflow 1, plus the overflow, okay, which is A. That's times the offset, which is 1978, so 1,978 A's, plus the return, which is 4 B's, plus the padding, which is nothing, plus the payload at this time is nothing, plus the postfix, which is nothing at this time. Alright, so we can go back into here. So let's go ahead and start that machine back up. Get him back up and running again. Remember we talked about yesterday, controlling the EIP value is our main goal with all buffer overflows. So let's go ahead and set this off and see if we can control that EIP value with 4 B's, which will show up as 42424242. So we'll do a Python 3 again, overflow 1 exploit.py. We come back into here and we see that sure enough we get 4 B's. So 42424242, So we know that we can now control that EIP value, right? Awesome. And as you can also see, we have those A's up on top, right? And we have our A's like right here. So we know that we can control this whole guy. So 1,978 A's is where we want to be at. So now what we can do is we need to find the bad bytes. Like I said, they have a Python script on here for you to find bad bytes. You scroll down and it is 4x in range. Okay. And that's going to be a Python 3 script. So we can type in Python 3. Mine is called badcharacters.py. And x00 is not one of those characters. That one's pretty much always bad. So we're going to go ahead and copy this guy now. There we go. And we're going to throw him in as our payload. Alright. As you can see, I kept those 4 B's on there. I kept that overflow on there. And then we're also going to throw in this payload. I think I keep the 4 B's on there. I never remember. Let's see. Let's see if I kept those 4 B's on there. Nope, 100% did not. Let's go ahead and get rid of those 4 B's. I always forget that part. If I keep them on there, I usually do it, and then I'm like, oh, messed it up. Alright, so we'll go ahead and save this guy. So we're going to go to 1,978 A's. Right? There's going to be no return value anymore. No padding. And then we're just going to send out this payload of bad bytes that we just created right here. So let's go ahead and get back up here, and we'll do a Python 3. Let's make sure our program's up and running first, which it is not. Control F2? Yep, Control F2 to go back to just make it run again. Instead of hitting F3 and then F9, just hit Control F2 then F9. That'll make it run also for your hotkeys. Or you can hit this little back eye right here. And what we're going to do now is Python 3, Overflow 1, exploit.py, enter. And now we see that we crashed again. Alright, we got all of our A's there. EIP value is not the B's anymore because we got rid of those B's, right? But we don't care about that. We actually want to follow the ESP value, and we want to follow that in the dump. If we look at this, we can see that we have 1, 2, 3, 4, 5, 6, and then 7 looks like it's bad. And it actually looks like 7 and 8 are bad. That's due to 7 being bad, 8 is also going to be bad, a bad byte. So we want to get rid of 7 first. So right now it looks like x07 is a bad byte. And we can see that like right here because it says 0A. That's not correct. So we have 1 bad byte so far. So we come into here, right? And we just want to go ahead and just wherever we really want to, as long as we just do a little that guy, okay? And we'll say bad bytes, or we can actually put them right down here. We'll put them right here. Okay. We're going to say bad bytes. We have x07. And then we come up here and delete x07. Okay, let's save that just in case. We're going to skip for now saying x08 is good. We're just going to say x07 messed up x08. So we're going to skip that one for now. We got 9, 0A, B, C, D, E, F, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 1A, 1B, and we just keep working down this guy manually. This is the manual exploitation I was talking about the other day. Manually to see if there's anything else. 2D, this 2E is a 0A. That looks like it's bad. You're not always going to get 0A, but on this one we are. So this one looks like it's bad. That's 0A, like right there. So let's go ahead and minimize this guy. And we'll say 2D, so 2E is bad. Okay, so X2E. Alright, and we know that X00 is a bad byte, so we'll say X00 at the beginning. Let's go ahead and search for him. Control F, 2E. Alright, there he is. Let's go ahead and get rid of him. Save that. Alright, that's all good. All we're doing like right now is just finding the bad bytes, which we did the same thing as yesterday. We're just manually doing it this time. So 2E, that would be 2F. We're not going to say 2F is a bad byte yet, just because, you know, 2E may be messing with 2F. So we're not going to say that's a bad byte yet. 30, 1, 2, 3, 4, 5. Alright, and all this is just a big eye test to see which ones are the bad bytes. And once you're done finding all of your bad bytes, you obviously want to do this again. Look through the whole thing and see, did you catch all the bad bytes? Alright, because it's very, very easy, obviously, to miss some. You can use a motor script for this also. I don't really like the motor script very much. 9F, this one's wrong. See how it goes 0A then 0D, and then it goes A2. So all the other ones were 0A also. I think that this one's also wrong. So whatever comes after 9F is incorrect. Alright, so we're going to go ahead and look at that guy. Let's search for 9F, and we'll see what comes after that. 9F, and it's going to be XA0, which is also usually a bad byte in Windows programs. So we'll get rid of that. That was XA0, right? So we'll come back over here. We'll do a /XA0. Now, I would highly suggest you guys go through this. I think that after we do this one, if you're into this stuff or if you're going for OSCP or anything like that, you're going to do the rest of them. But for now, that is all the bad bytes. X00, X07, X2E, and XA0. All right, those are the bad bytes. So instead of spending a whole video doing an eye test, we're going to go ahead and say, all right, cool, hit the I believe button, and we'll keep moving. Right, so let's go ahead and save this exploit now. And remember, we did get rid of all the bad bytes up there. Now, usually what I like to do, like for like tests or something like that, or like the CPT test, the CPPT test, things like that, afterwards, I would send this off again. Right, and I would look at that whole thing again and see, do I have any bad bytes? Right. Yesterday, we also went through and we did the Mona byte array, and we utilized that. This time, we just didn't do that. That's all. I like doing it manually. I think it's better to do it manually because I feel like Mona sometimes misses stuff, and it gives you some that you're like, huh, like there'll be one bad byte in the beginning, and like the next 5 will be bad. You know, that's what it'll say, something like that. So then you're getting rid of way too many. You're trusting the program too much, and it's just not. I just don't think that's how you should know how to actually look through it. We'll go ahead and follow that and dump again at the ESP value, right? So we got 1, 2, 3, 4, 5, and we go all the way down, make sure there's no more bad bytes. And once we're comfortable if there's not, we go ahead and say, okay, cool, I found all my bad bytes. Right? So now what we want to do is we want to find a jump address. Now we are going to use Mona for this. We're going to say Mona, all right, and I always have to look at my notes for this one, like right here, which is why I take notes. Finding my jump point. Okay. Now we're going to do Mona JMP TAC R. Let me go ahead and grab Mona here. There we go, or not Mona, but my immunity debugger. Mona, JMP, TAC R, ESP, TAC CPB, and then all of our bad bytes that we found, which we found X00, X07, X2E, and XA0. And this is going to find our jump points. We hit enter. And he found our jump points, then he disappeared. That's okay. All you have to do is just minimize the CPU, and there you go. There's all of our jump points, like right there. All right. So we have a bunch of jump points, like right here, right? What we're looking for is everything to be false. Okay. Now some of these things, depending on what test you're taking, some of these might be true. Okay. Right now, ASLR is false, rebase is false, safe SEH is false, and OS is false. Okay. That's okay. Every single thing can be false. That's what we're actually looking for. But depending on what test you're taking, some of these might be true. Just continue on. Just continue to do the same thing, okay? So we have this, like right here. Let's go ahead and grab that first one. We'll use this at 625011AF. And remember, we have to put them in little endian format. All right, this is the same exact concept that we did the other day. So this is the exact one that we're going to grab, 0x625011AF. So I'm just going to copy him. We'll bring this back over here, and we're going to do a little pound sign and say jump, because the pound sign allows it to not be ran right. And what we have to do is this is going to be our return address, but remember we have to put this in little endian format, right? So this is going to be /AF /11/50/62, and those are all X's. Should be like that. I think it's like that. If I remember correctly, it's like that. This is why I keep notes. Hey, I did the slashes the wrong way. I was about to say, it shouldn't be that color. Maybe I should just look right here and realize I did the slashes all the wrong ways. There we go. And then there we are, okay? So what we did, remember, low endian format. Okay, we're starting from this side. So AF, AF, 1111 50 50 62 62. Okay, and that's our little endian format, right? Control S. We're going to save him. Okay, we now have a payload. Well, let me go to end. We'll delete this. We now have bad bytes. We found all our bad bytes, right? We found our jump point. We know our offset. Let's go ahead and add in some padding for that NOP sled, right? We want that NOP sled, like we always talk about, which is going to let that program shift like a little bit with those bytes and everything, and it'll slide down and still hit our payload. Okay. And if you watch the video that David Bambal, his name, does, he explains that very well. The one that I pulled up yesterday. If you watch that video, he explains the NOP sled and everything like that very well. All right. So now all we have to do really is just make our payload. So we're going to make our payload. I'm going to kind of move this guy over like a little bit so we can actually get our bad bytes. We can actually see what they actually are. We're going to get this guy pulled up. And obviously actually just going to copy this like right here. There we go. So what we're going to do is MSF Venom, TAC-P, Windows, / shell reverse TCP. Alright. Our L host, right? 10.98.166. That's my IP address for my box. Let me make sure of that. And remember, this program is running on 1337. So 10.98.166. L port is not going to be 1338. Program's running on 1337. Not going to be able to use the same thing. TAC F. What type of file type we're going to make it? We'll make it a C. Okay, we'll write it in C programming. TAC B. What are my bad bytes? Right. There we go. That is 100% not it. Whoopsie daisy. Our bad bytes are these guys like right here, right? We'll copy him over. There we go. And then exit function equals thread to make it, if it fails or if anything happens, it just exits better. It doesn't like crash, doesn't look like crap or anything like that. Okay. Let's go ahead and get back into our program here. We'll start that back up again. Control F2, F9. Alright. And what we should technically be able to do now is actually get a reverse shell. So that took us, what, 15, 20 minutes, I think? Maybe not even. 22 minutes, okay? 22 minutes to get a reverse shell with a buffer overflow. Hopefully we do. I shouldn't say it did. Hopefully it does, right? So let's go ahead and go to payload. Parentheses here. Control-Shift-V. Parentheses down here. Alright, we don't need a postfix. We have our NOP sled. We found our jump point. We have our overflow at 1978. We're going to connect to this IP address. We have the proper port. We have the proper prefix. Who are we attacking, right? And our whole payload's encompassed by these parentheses like right here. And that should be about it. Alright, so let's go ahead and Control S. We'll save him 100 times. The program is running on that Windows machine. We'll do a Python 3 overflow1 exploit.py. Let's go ahead and get an MSF console up and running. So one thing I almost forgot is we kind of need to have, a listener. Let's use exploit multi-handler. And remember, you could also just use netcat for this. Alright, so we'll do set the local host to 10.9.8.166. Set the local port to 1338, right? Because that's what port I made it up here. 1338. Set the payload to what I made up there. Windows shell reverse TCP. And we'll go ahead and run that. So he's running now. Now I should be able to fire out that payload, and hopefully we get something back down here. And we do. Alright, so we are in there. Who am I? And we are OSCP buffer overflow prep admin. Let's go ahead and do a who am I /priv. Alright, we got some privileges here. Let's see if we have, we got person A privilege, so we might be able to use a print spoofer attack, something like that. So you can start messing around with this guy after this. Now, what I did after this was back around the session, I did a search for shell 2, because we can use shell 2 interpreter. I said use 0, set session to 1. I ran that, right? And then what I did from here was I did a get system, and from there I ended up downloading all the other exploits that they have. So now I can put all these on my local, Windows machine I have. Because right now I'm going through remote desktop into a Windows 7 machine. If I want to try these same things out with Windows 10 machine, we can do that. Right? So now I can go to sessions 2, get system. Right? We got system. Let's see where we are. Like right now, pwd. Let's go ahead and cd back. pwd. Let's see where we are. Okay, directory. We got vulnerable apps like right there. So we can download all these guys like right here. Right, the brain pan, do stack buffer overflow good. We can go into the Vol server, download him. We can download this guy if we really want to. But we can download all these different ones, and yeah, have put those back on our local machine and have them ready to go. So now we did that. Let's go ahead and see if we can do number 2 like real quick. CD into Overflow 2. Alright, I already have my bad characters, my exploit, and my fuzzer. Remember, this fuzzer could be the same exact thing that we just used. So let's go ahead and start this program back up again. It's still running because we have the exit function thread. So it's still running. I'm still going to just, hey, you're going to start back up totally again. F9, there we go. Alright, and this time we're going to go do a sublime for exploit.py. We're going to go ahead and move this one. This one's already on Overflow 2, okay? I already know my offset and everything, but we're not going to take all that, right? We don't want all that to be in there because we just got here, right? We just got here. Okay. So we're going to delete all that stuff. We'll delete this whole guy. And that should be it. Let's go ahead and change our IP address to the correct one, right? There's that, and then let's go ahead and get back into here. Let's go ahead and change the IP address to the correct one. And let's make sure that our fuzzer is on the correct IP address also. So we're going to go into, we'll actually move exploit.py to overflow 2 exploit.py. Go and cat the fuzzer in here. The fuzzer in here is showing overflow 2 and everything, so let's go ahead and start our fuzzer. The IP address though is wrong, so we'll sublime that fuzzer, fuzzer.py, and we'll go ahead and change that IP address to the correct IP address. Whoops, I just hit Control C instead of Control V by accident. There we go. Control V. Okay, we'll save that. And we're just going to run through this guy extremely quickly because Alexa and I are going to watch the movies tonight and actually hang out. Since I've been doing this a lot lately. So let's go ahead and do a Python 3 fuzzer.py. Alright, it's fuzzing that overflow 2 now with however many bytes. Remember, 1 byte or 100 bytes at a time. We'll see how far it gets. It's going to pause for 1 second. And it looks like we crashed at 700. So let's go ahead and do our MSF pattern create. Right? TAC L, we'll do 800. Okay, make it longer, right? Let's go and grab him. Throw him into our overflow 2. Okay. We'll throw him into, I can actually go ahead and exit out of there. Exit out of exploit.py. Close without saving. Yep. Fuzzer.py. Okay. Exit out of those. I have overflow 1.py. I can actually go get out of there. I'm going to do my sublime text for overflow to this guy right here. Exploit. So our payload. We're going to throw him in there. There we go. Let's go ahead and fire that off. Let's go ahead and restart this program. So we know that it can be broken, right, with the fuzzy and everything. We have an idea of where it can be broken at. Now, if you're wondering why we just don't send off like 1,000, just do a pattern create, send off 1,000 every single time, or 5,000 or some crazy thing like that, you can actually overwrite so much that it messes up more than what you want to, and you won't get the correct pattern there. So the correct offset, things like that. So let's go ahead and do a Python 3. All right. Overflow 2 exploit.py. Maybe not. Maybe we won't. That was a joke. Okay, so offset. Oh, offset needs a 0 byte. That's why. If nothing's in the offset, it has to have a 0 because it's looking for a number there. You can't do an A times something with nothing there. Go ahead and do that. Alright, and we'll go ahead and send that off again. Set the evil buffers, and the program did crash. Cool. So we'll come back over here, and let's go ahead and do an MSF, or let's see where it crashed at first. Excuse me. So it crashed at, we have 413-17641. 413-17641. We're going to do this. Crashed 413-17641. Is that correct? 413-17641. Yes, it is. Okay, cool. So we'll copy that down. All right, minimize him. Do our pattern offset right. MSF tag pattern underscore offset. Tag L. This time it was 800. Correct. We set off 800. Tag Q. There. And the exact match offset is 633. All right. So let's go ahead and say okay. So 633. So we'll say offset is there. Where's my Sublime text? There we go. Why are you so small? Crashed at that. So we'll say offset 633. Now you're going to notice that that's wrong, but we're going to try that first. Okay, so we get rid of the payload. We're going to send all those A's right, and then we're going to send 4 B's. Okay, cool. There we go. Control S. So we're going to send 633 A's, correct? And then we're going to send 4 B's. So let's go ahead and make sure that program started back up again. Awesome. Control F2. F9. Alright, awesome. And then what we're going to do from here is we're going to send that off. Put down 3 overflow 2. Set the evil buffer. We come over here and we notice that we did not fully write over the EIP value. We still need 4 more bytes. Or 2 more bytes, excuse me. We still need... So what happened there? So let's go ahead and add on another byte on there, because we need 1 more byte there, right? Keep saying different numbers. We need 1 more byte. So let's try 634. Okay. Now that's okay. That is okay. That was what I was talking about with things shifting, stuff like that, okay? And you may have a different number. So I think my last one was a different number even than that. So you may have a different number there. That's okay. Do what you look at and what your gut tells you. Like, mine's different. That is okay. So now our EIP is now being controlled. All right, with 42424242. Actually, that might be the only one that can be. Let me go ahead and look at the questions. Oh, thank you very much. Yeah, it is 634. All right, so now our EIP is being controlled with that 634, right? So now what do we have to do? Now we have to go in there and we have to do our bad characters, right? So let's go ahead and do a Python 3 bad characters.py. Grab this. I also put all these on the GitHub link that I sent out before. So grab our bad characters. We'll go ahead and we'll get rid of those 4 B's. Our payload is going to be those bad characters. Okay. So our payload is those bad characters, right? And from here, what we can do now is we can now restart this program. Control F2, F9. He started up right. And we will now send off, or we'll now fire off those bad characters and see what we get for that. All right, he went through. All right, obviously it crashed and everything. We want to follow, remember, the ESP. We're going to right click, follow that and dump if we can. It is frozen. We broke it. Whoa! We have broken the exploit. We broke a little bit too much. We're just going to have to go ahead and exit out of here. We're just going to have to remote desktop back into it. That's okay. Let's go ahead and get that remote desktop information that we want, which is in deploying VM. Boom, there we go. We'll go ahead and copy that in there. 10.10.104.25. Where's that guy go over here? 10.10.104.104.25. Right. Hopefully he gets something. We'll go ahead and restart that program and send out that exploit again. And then we'll send out those bad bytes again and see if we can find all the bad bytes in there. So I'm going to let you guys go ahead and look through it. I already know what the bad bytes are. I already have it written down and everything. So I'm going to let you guys go ahead and look through it and see if you can find those bad bytes in there. Pretty much get a copy of what I have over here, what I've already done. And if this guy doesn't open up anytime soon, we might not finish this one off tonight. So we might not finish him off actually at all tonight, because this one's about to just about be over, and it looks like free RDP is acting up. Let's go ahead and terminate the machine. We'll get them running again, and then we'll try from there. I think we broke it. That's what happened. I'm gonna grab a quick drink, and we'll try to get him running again from there. It happens. I mean, we are buffer overflowing the machine. That was the second time we got buffer overflow right there. So. So remember, one of the main things to remember with this is controlling that EIP values. Okay, if we're also talking about EIP, we're also talking about 32-bit. If we're talking about RIP, we are talking about 64-bit. Which Linux and 64-bit, that'll come later on. We'll do all those things later on, but as of right now, we need to control the EIP value. That's what you're going to care about for OSCP. That's what you're going to care about for ECPPT, and all those ones. So those guys are, the buffer overflows of them are not very difficult. Let's go ahead and make sure that everything's good in there. Overflow exploit.py. We already have the offset and everything, so we're not going to go through all that again. What we will do, we already have to change that IP address out though. So I'm just going to delete him like right now. Should be 1010 something. If I could type. And it looks like 1010 66.127. 66.127. Okay, so let's go ahead and X-free RDP into there. Whoops, that's not going to work. 1010 66.127, I said right? Yep. Okay. And hopefully this one works now. Alright, start that Immunity debugger, right? Immunity debugger. We'll get that vulnerable app in there again. OSCP app. Okay, like I said, there are 10 of these, so you know you have all the time in the world to do these guys. Plus, you can bring them back down to your old computer. I mean, there's not much else you can possibly do with these guys. With well, not much you couldn't do. So there's our OSCP, right? Go ahead and get him up and running. Press F9 so he's running, and we'll get back into this guy. So we got our IP address now. We already know our offset. We're going to send out those bad bytes, correct? So let's go ahead and do a Python 3 overflow exploit.py. Okay. He should have crashed. And we're going to right click on ESP, correct? And we're going to go to follow and dump. And let me go ahead and do appearance first. Font size, and we'll do font 6 again, so you guys can see everything all nice and pretty and stuff. There you go. ESP, right click, follow and dump. And then we start from the top. X00 is already a bad character. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F, 10, 11, 12. So we're just going to follow this guy down and try to find as many bad characters as what we can. There's already one like right there. So X23 is a bad one, which means that X24 is most likely good. It's just being blocked out by X23. We just keep going down and try to find all the bad characters. Okay, there's another one I just found just from looking. So there's X83. Okay, so X84 is most likely a okay. So there we go, right? So like I said, I already did this and everything. So I'm not going to go through it, the whole thing again. And look for all the bad characters. There's actually 23. There's 83 like right there. I got 3C and BA, and obviously X00. So those are our bad characters like right there. So now all we need to do is create that exploit, right? So MSF Venom, TACP, Windows, shell reverse TCP, port 1338, C, right? We're writing it in C shell. B, the bad bytes, going to be these guys like right here. Okay, exit function threads, so that exits more easily. Okay, we'll hit enter on that. Start up another thing. NC tech LVMP 1338. We'll do it with a netcat this time instead of Metasploit. Like I said, this one's going to be a lot faster because we just did this. Let me go ahead and grab him. We'll go to our payload, and we still have yet to find our offset or our return value, so I'm getting way ahead of the game here. I'm going to delete that. I'm getting way ahead of the game here, aren't I? So we still got to find our return value. That's okay, because we can put in everything else as of like right now. Actually, can we even put in everything else? Yeah, because we just do our motor jump, so we can. We needed to find our bad bytes before we could even put in our return value anyways. I do that every time. Let's do times 16 again. And let's go ahead and find that return value with our motor jump. Alright. So let's get that immunity bugger back up and running. Alright, we'll do Mona jump. And I always forget the command line for this guy, but that's what notes are for. Mona jump. Tech R, ESP. So we got motor jump, tech R, ESP. Let's go look for the ESP, tech CPB, which is going to be our bad bytes. Our bad bytes are right out here, actually. Right there's our bad bytes, right? So let's go ahead and do that. That's going to be X00. Slash X23, X83, slash XBA, right? And our quotation marks there, hit enter. Like I said, if he just all of a sudden disappears, that is okay. We'll just go ahead and minimize the CPU down, and there's our jump points. All right, so we got 625011AF. Now, if the first one doesn't work, just keep moving down the jump points. Like I said, everything over here is false. Okay, so there's no type of security really on here. Alright, so let's go ahead and get back into this guy over here. And we'll say, hey, we got a jump point. And that jump point is, and he is 625011AF. So say 625011AF. So now we need to make a little endian, correct? XAF slash X11 slash X50 slash X62. And now he's now a little endian. Alright. So easy day, right? So let's go ahead and save that now. So what we have now is we found where the program crashed at, which gave us the offset, right? We are going to times that offset, but remember, the offset didn't really work for us. So the first time I actually had 632. The next time I did this one, I had 633. So who knows? You might have 634 for your offset. All right, so I got that offset. I sent those 4 Bs out for the return, saw that didn't really work, so I had to up the offset by 1, which gave us our 634. I then sent out the bad characters. We found out what the bad characters were. Right. From there, we then made our payload. We did our padding, and we got our return address, our jump point. So we should be good to go with this payload now. So let's go ahead, and we have our listener down here. And let's make sure he's up and running, which he's most likely not. He's not. Okay, so let's go ahead and get this guy up and running. And we will go ahead and do a Python 3 overflow 2 exploit.py, and we get our reverse shell. So there you go. There's 2 buffer overflows on Try Hack Me in 44 minutes. So, and the second one took about 10 minutes maybe. So there you go. I hope that helped you guys out. I hope that gave you guys a little bit like, oh, thank God. Like, it is obviously doable. Stack base is what you see in both, is what this is, and also what you see in both CPPT and also OSCP. Those are both stack based buffer overflows. So you don't have to worry about heap base. You don't have to worry about no execute. You don't have to worry about x64. OSCP even gives you a Windows 7 machine to do this with. CPPT does not. But as we saw yesterday, you can download them and you can load them onto your Windows 10 machine or your Windows 10 VM, Windows 10 VM, and you can use it like that, which I would highly suggest you do that one. Has my face not been on here the whole time? I do apologize. I don't know why it's literally just a black screen down there. That is super annoying. I am sorry about that. I didn't even notice. I'll just turn that off. I am very sorry about that. That is very annoying. You know what? Just because of that, I'm now going to do it again. Where is it? Video capture device. What are you doing? Now you see my whole face, and that's it. That's all you get to see now. Alright, I apologize for that. That black screen down there. No one in the chat told me. Nobody. Alright, but yeah, that's going to be it for this one. I hope that taught you guys something. I hope you guys learned something. I hope that was helpful. So, if you have any questions, hit me up on Discord. Hit me up on YouTube here. On the YouTube. Not YouTube, but the YouTube. And, yeah, you guys have a good one.